going to be doing is being introduced to the circuit simulator we're going to be used. We're going to use it initially, start the session, to simulate the circuits you did last week. So you'll be comparing what the simulation says with what your calculations were, and you should find that they concur. That's a good way. I thought it'd be a good way to introduce a circuit simulator with a familiar and relatively easy circuit to simulate. Alright, so we're going to be using something called the Quite Universal Circuit Simulator, or QUCS. That is freely available on the internet, and I'll put the web address up in a minute so you can go and find it. You can put it on your own machines. It works on Mac and on Windows machines. Okay, so that gives you the opportunity. If I put anything doing simulation in the assignment, it means you haven't got to rely on necessarily being able to get that work done here. Okay, so so we're going to use the simulator to simulate your circuits from last week. So that's the R1 in series with R2 and R3, calculate all the currents, voltages, etc. Alright, and then once that's done, we're going to introduce what's called the superposition theorem to calculate values in circuits with more than one source, or more than one battery if you like, okay, more than one DC source, and then we'll again use the circuit simulator to confirm those results. Alright, so instead of practical this week, it's kind of simulation practical. Alright, so what I'm going to do by way of example, that's the styler circuit you had last week. So we've got R1 here in series with these two resistors in parallel, and I'm going to use values of 1000 in my example on the board, 270 for R2 and 330 for R3. Okay, and I've already done my calculations and I've put them over here. So I calculated the total resistance, I calculated the three currents here, and the value of V2 and V3, which we know are the same because those two resistors are in parallel. Okay, and I've checked that these two, considering I've rounded the three significant figures, add up to that one, so I've confirmed Kirchhoff's current law. Okay, so we can simulate that circuit on this circuit simulator and check those results. So, like I said, QUCS, freely available as an open source simulator, so you can download it for your personal machines. It's available for Windows and Mac, and that's from that address there. If you Google the full title, Quite Universal Circuit Simulator, you'll find it. And just do the latest download and install it on your machines. Works with Windows 10. I've got it on my laptop here, and I've got it on my Mac at home, and it works perfectly on there as well. Alright? Everybody happy with that? Okay then, Quite Universal Circuit Simulator. I'm reliably told by our IT department that the simulator's got an icon on the desktop, so we'll keep our fingers crossed about that one. Okay. When it opens up, you'll have an untitled circuit page, as here, and you can start to build your circuit. Now, one thing this simulator and all the ones I've ever worked with need is they must have at least one ground, 0 volt reference point, which you do with this icon up here. So for me, that's always the first thing I put on my diagram. Now, you can have multiple grounds, so if you've got a complex circuit, instead of trying to get all the wires around the circuit and back down to the one ground, you can put multiple grounds in the circuit and they're all connected together anyway, so you don't have to do that. And I can show you how that works. I'll show you how that works. Okay, so the ground is available on there. When you want to get away from the symbol, you just go to the arrow pointer icon again. Alright, then over here we've got a components tab. Alright, and then up the top here we've got a drop down list, so you've got several different bins of components if you like. First thing I'm going to put on my diagram is my source. and I want a DC voltage source, and I'm going to plant it there just above the ground. Okay, not connecting anything together at the moment. It's quickest to do, put all your components on and then connect together. All right, you've probably done it with multi-sim. Yeah, multi-sim. This is slightly different because it doesn't have the meters, it uses probe, but it gives you the same results. All right, now what we also want is, in the lumped components department, we want resistors. If you put them in the order that you want them numbered, so I'm going to put R1 there. I'm going to leave a little space here because I want to put a probe in to measure the current. Put R1 there, R2 there, R3 there, and then press the escape key. It takes me back to the pointer. Alright, so all my components are on there now. I can start wiring them together. We use this icon up here and just connect them together like so. If you want to go away from there, you just click again, and then we can come off the end here. And like I said, instead of you going all the way back to here, you can, if you want to, put a second ground over this side, and those two are effectively connected together. Okay, so when things are more complicated, that makes it easier to keep your circuit neat because you can put grounds in several places. All right, let's move. You try and keep things tidy. Then, if you want to make any alterations, that's easier. Right. Oh, I know what I haven't done. Take that out. Take that out. Take that out. The other things we want on here are some probes. So in the list here, we've got probes, we've got a current probe and a voltage probe. So I'm going to put a current probe in there. What you need to do is watch which way the arrow's pointing. Can you see us pointing left to right on there? And that's the way we're expecting the current to go in that leg, because there's the positive symbol of the voltage. If you put the meter in the wrong way round, it'll show the current as being negative, like if you connected a real meter the wrong way round. All right, and then I'm going to put one up there for the I2 current and one in there for the I3 current. And now connect them together. Like so. Yep. Alright. Then, if we come out here, we can right click on the voltage component, edit parameters, and make that 15 volts. We can edit the properties and just change that to I1, because that's what we called it on our circuit diagram, and you can do that for I2 and I3 as well. Change that to the value. So a voltage probe. Remember, we across a component. So I'm going to put touch off in parallel. All right. And again, get your wiring tool Connect the plus up to the more positive side. And go on. Alright. So what I want you to do is get that far. Let's just have a look at saving. Just to make sure you save, I'll let it simulate until you save. So while drive or you so if you can get that far, it'll take you about 10 or 15 minutes. Back to the front. I'll show you how to do this. So I haven't filled up the stuff. I've changed all my values, the ones that I specified. I2, I3, so I can easily recognise and VR2 and VR1. So to do the simulation, the first thing we have to do is put the simulation onto the diagram page. So you go to simulations, and all we're going to do is a DC value simulation. So you just put that on there, press the escape key, or go back to the arrow. Okay, and once you've done that, there's no for this simulation. A button that looks like the gear up. Pretty quickly for such a simple thing. Then puts you onto another page and automatically come up with diagrams. All we want is a formula. We place it on there. And then that asks you which values from the table. So we want to know A1. What that's saying is that's I1 and that's a current. And if you look, when you double click them, they pop over into this graph column here. So I2, I want, I3, I want VR2. Right, okay. And as you back to the table, that table a bit bigger. You can see 1 milliamps as I1, 7.1 amps as I2, 5.8 milliamps as I3. The volt drop across R1 is 13.1, and the volt drop across R2. We'll add those two together, we get approximately for calculation London, and if we add these two together, we should get the okay. You to do that for your circuits and confirm you get an error, same result. We're practicing. So the only things that come out of that, that's quite a simple circuit, but we know we've already tried. We're gaining confidence in this simulator that that's given to the right results. And so you could go and design a software, results, and then build a practice. You can find you can do the calculation we learned last week and have got to be doing. You can do your that you get the same result that it gives you. Alright? You really wouldn't want to use a simulator for a complicated circuit unless you're proven in your own mind that's giving you the result you would expect it to. Alright. Off you go and simulate your circuits and see if you get the same result.